All right, everybody, welcome back. We're moving right along in chapter 12, this time looking at exponents and multiplication. And again, there's a great activity lab. If you would like to take a quick start looking ahead at exponents and multiplications, you can try the activity lab on page 570. That is an optional activity that just could be a kind of cool one to get you started in this, what we're doing today. So looking at exponents, writing them as standard form, as an exponent, etc. We're going to start with our exponents today. And our big idea is multiplying powers with the same base. So this was just an optional. We are going to be getting into, on page 571, example 1 in this first video. As we get started, if you want to look at that yellow box in your book, the key concepts, multiplying powers with the same base. So when we multiply numbers or variables, notice this is multiples with the same base, we add the exponents. I want to point out, though, one of the common misconceptions is that we can add numbers or variables with the same base and add the exponents, but this is only true when we are multiplying factors together. So if we looked at our first example is actually, or our first introduction is actually above the example, 3 to the second times 3 to the fourth. If we were to spread those out and write each of them as a product, 3 to the second power means 3 times itself 2 times. In other words, 3 times 3. And then we're multiplying that by 3 times itself 4 times. 3 times 3 times 3 times 3. Now, I have these in parentheses to show which they came from, but multiplication says I can multiply these together in any grouping that I want. So I could take away those parentheses and look at this as all one big product. And now I can see 3 times 3 times 3 times 3 times 3 times 3. This is 3 times itself. Well, how many times? 1, 2, 3, 4, 5, 6. So I can add the exponents. 2 plus 4 is 6. The same is true when we have variables. The general case for this is that a to the m times a to the n power. So same base multiplied together with two different exponents is the same base, and I add the exponents. So our example 1 has -2 as a base. -2 to the third power times -2 to the fifth power. Now I could rewrite this as -2 times itself 3 times and -2 times itself 5 times, but I know that this is the same as -2 to the 3 plus 5 power. 3 plus 5 is 8. If I am simplifying, then I'm done. If I'm simplifying the exponents. Now, I know that I could actually multiply this and find a number. This is equal to some number in standard form. You could, in your head, maybe you want to count 2 times 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 2 and do that in your head. But you can also use our handy-dandy calculator. Now, one thing I want to point out here that's super important is when the base, like in example 1, is a negative number, our calculator, or when we use our calculator, we have to put that base, -2, in parentheses. And then we can use the caret button, the up arrow, and pick our exponent. In this case is 8. I push the right arrow to escape, to get out of that exponent. And then I can find out what is -2 times itself 8 times. Now notice if I was to skip the parentheses, -2 to the 8th power, I get a different answer. That's because this expression takes 2 to the 8th power, that's 256th, and then puts that negative sign on. So it's actually 2 to the 8th times -1. Whereas our first expression takes the base -2 and multiplies that base over and over again. Be very careful when you're using your calculator. In the calculator, use parentheses. Take a second to try some of these where you're simplifying them to this spot. You don't need to write them as a standard form, just simplify the exponents. Parentheses. I skipped a pair. All right, try quick check 1A and B. Alrighty, you should have paused and tried those. Our answers here now for part A, 6 to the 2nd times 6 to the 3rd. We add 2 plus 3 is 6 to the 5th power. And B, -4 times -4 to the 7th. Well, there's no exponent in that first. So what exponent could we put here? Well, we can actually have a placeholder of 1 when there is no exponent. It's just itself once. So when I add 1 plus 7, I get -4 to the 8th power. So when we don't see an exponent, we can use that placeholder of 1. And finally, you may not have tried this one, but for C, we can do the same thing we've been doing. Even though this is a variable, we can still add the exponents. If you haven't tried it, pause your video and try this one. Okay, we can add the exponents 1 and 12. We have the same base, m, and an exponent of 12. Alrighty, part 2, and we'll keep working through multiplying these. Look forward to those next videos.